asymptotes. All right, so let's see, can we identify this function? So it is either a secant or a cosecant, right? That's the shape of that function. And then thinking about asymptotes, the cosecant has an asymptote at the y-axis. So I'm thinking this is a cosecant. So now I just have to figure out what kind of stretch or shifts happen to this. So that's where trying to redraw it would help. So I'm going to use my notebook paper here and take a screenshot of that. Oops, where'd you go, screenshot? There you are. Okay, and this is number 6 from homework, 6.2. So again, I believe that this is going to be a cosecant. And remember, cosecant's related to sine, and sine would cross through the origin here and come up and hit that peak, go down, hit that peak, if it's centered at y equals 0. Now looking at this, I can see the minimum here is further from the x-axis than that maximum there. So the center line isn't y equals 0. So let's figure out what the center line is. So to get that midline, we find the difference between the, we find the average of those two values. So we have a min here of 2. And we have a max here of -4. Cut that in half. So same procedure we use for sine and cosine. So that gives me -2/2, which is -1. So y equals -1 is the midline. So this was shifted down. And that's just a little off there. Just you a little, there we go. So there's my midline. And then notice that it's not 1 away from the midline. So that means there was a vertical stretch here. And so I can see that the distance from here to here is 3. Same thing, distance here to here is 3. If you're not sure about that, to find, that's what we call our amplitude of a sine wave. And remember, this is related to a sine wave that would come up, go down and up, but it's the reciprocal of that sine wave. So if I take that 2 plus, or this time we want to go 2 minus -4, cut that in half, that's going to be 6/2, and there's that 3 I observed in the graph there. So that's the vertical stretch. And since this is centered on that vertical asymptote, y equals 0, there's no phase shift on this thing right here. So again, I'm seeing that this is related to the sine, which means it's a cosecant. Oops. Oh, we got to adjust the period. I almost forgot to do that. So we're going to have a period adjustment times x. We got to figure out what that is. It is shifted down 1, and it is 3 times stretched y-wise. So for the period, all right, so this repeats itself when, let's make another line here, in between these two vertical lines from here to here. So what is that? A distance of 4. So this has a period of 4. And we know that the period is 2 pi divided by whatever this number is. We usually call that b, multiply b up and the 4 down. So it looks like pi/2. So let's graph it to make sure. So we think we have the graph there of y equals 3, cosecant pi/2x minus 1. And again, you got to play around with a picture, so you got to redraw that graph. I have the gift of this screenshot thing I can scribble on. I trust you guys could trace that on a piece of paper. And let's use, how about Desmos today? graphing calculator. And I think I have the graph of y equals 3 times the cosecant of pi over 2 times x, close parentheses, minus 1. And so then let's double check that I got the period right. If I graph x equals 4, I should see that contains 2 segments of this that then repeat. So that looks good. And then I have a point here at 1, 2, and a point here at 3, negative 4, oops, which that's what it looks like here. 1, 2, and 3, negative 4. Yeah, looks like I got the right graph. So this is the graph of 3 times the cosecant of pi over 2 times x, close parentheses, and it's shifted down 1.